Hi, everyone, and thank you for joining us for today's webinar, What's New in Femap 2306. My name is Jonathan Hill. I am a business development engineer here at ATA Engineering, and I'm based out of our Herndon, Virginia office. So my responsibilities are sort of, coordinating support for our customers on the East Coast. I'm really excited to be joined by my friend Andy Haynes today from Siemens Digital Industry Software. Andy is going to fill us in on all the really cool and exciting new features in Femap 2306. So I want to get to that quickly. Before I do, though, I'm going to give just a quick intro to ATA Engineering in case you haven't heard of us before. So ATA Engineering provides high-value engineering services focused on test and analysis-driven design. We're very passionate about helping our customers solve their toughest multidisciplinary product design challenges. And as you can see here, these are just some of the industries we support kind of across the board, anything aerospace and defense related, but also extending to themed entertainment and other industries like that. We are an employee-owned small business with a full-time staff of just over 200. And as you can see on the right, we have a majority of our employees are engineers, and the majority of those have advanced degrees. We have 7 nationwide offices, so chances are pretty good that we have one pretty close to wherever you're calling in from. And if you were trying to sort of, condense our expertise down to 3 bullets, which again is, I think, a little ambitious, those 3 would be design, analysis, and test, all in the mechanical design side of things. So on the analysis side, we have decades of experience with everything from structural dynamics, thermal analysis, fiber acoustics, to fluid dynamics and multi-physics simulation and more. And then on the test group, we're actually, or the test side of things, we're actually the leading independent modal test group in the United States. And so in that capacity, we have a lot of experience shipping out our shakers and accels and all that to wherever the aircraft or spacecraft or whatever the test article is, conducting that modal test, and then usually using those results to then correlate our finite element models. The other cool thing that we're able to do is we're able to leverage all of these decades of project experience supporting our customers and their various projects through our role as a Siemens partner and value-added reseller. So in that capacity, as you are looking to bring additional capabilities in-house, and as your team grows, you can look to ATA for software support for anything in the Siemens portfolio, really. So our expertise is on the Simcenter analysis side of things. So that includes Femap, which we'll be talking about more today, but also Simcenter 3D, Nastran, Star, and a bunch of other really great products in there. It also includes NXCAD, Teamcenter, and most recently, Simcenter test and measurement software and hardware solutions. So for all of those products, you can come to ATA for licenses. And the really exciting thing is that we provide hotline support. So our engineers who are doing the project work are the same ones who would be picking up the phone to help you through whatever problems you might be running into. We also provide the training material for Simcenter Nastran. So if you were to go to Siemens and request, I don't know, an intro to dynamics class, for instance, you actually end up with an ATA instructor and material that we developed, and usually you're even in an ATA office for those classes. So after today's presentation, I would invite you to go to our website and check out everything that is on there. That includes product information, calendars for upcoming training and webinars and live events, as well as a hotline support form if you aren't feeling up for a phone call. And again, the best part, I say this every time, but the best part is our free resources. So we have on-demand webinars, such as this one day, free Femap APIs, white papers, and more. So again, please go check that out when you have a chance. Also, feel free to send us a note if you have ideas for a future webinar topic or an API that you want to see or anything like that. Let us know. That's kind of how we come up with this content. So I'd encourage you to reach out to us for that. But otherwise, again, I'm really excited to have Andy here. Andy is a principal applications engineer for Siemens Digital Industry Software, and he's been on the Femap product development team for 25 years. So again, Andy, thanks for joining us, and it's all yours.
All right, thank you, Jonathan. Let me just share my screen here, and then away we will go. Let me just go into presentation mode.
Cool, looks good.
And there we are. Okay. All right, everybody, thanks for joining us today, and thanks, Jonathan, for that introduction. So again, what we're going to be talking about is what's new in Simcenter Femap 2306. I am going to go over a few things from 2301 as well in here. Most of them we added a little something or just certainly maybe enhanced something for 2306. So that's kind of why it's in here as well. So just so everybody knows, Femap 2306 was released in July 2023. And if you already have 2306 and if you have any issues with it, perhaps we will be putting out our first maintenance pack either by the end of this week or early next week. So sometime in September here, we'll be putting out 2306 MP1. Also, just in case you haven't visited a Femap webinar, you're not familiar, we're essentially on a 6-month release cycle. So we tend to do kind of one bigger release a year and one kind of smaller release a year. And then the maintenance packs, we don't do any UI or user interface work, I should say, during the maintenance packs, but we just fix bugs. And if there's something behind the scenes that we might want to fix or add some API capabilities, that sort of thing, that's kind of what we do in the maintenance packs. And typically, on average, you'll see at least 2 maintenance packs, and then maybe a third one or even a fourth one if needed. But typically we have 2 maintenance packs per release. All right, the first thing I'm going to talk about is some Teamcenter integration. So what we did in Femap was we added this entire PDM menu. So we now have direct support for Teamcenter. This was added in 2301. And I'm actually going to talk about just a little bit of an update that we did in 2306, but just in general, we got the whole thing working, more efficiently, better with 2306 from 2301. So again, we just now have this PDM menu where we have PDM Teamcenter, and you can sign into Teamcenter, open files, import a shattered JT assembly, and save, and we'll kind of go into that. And then this menu also took 2 pieces of technology that we used to have on the file menu. So we had a file share, which was got you access to accelerator share, and then the file references command, which you could think of was a really, really rudimentary PDM type of functionality that we had in Femap. So we moved, because of that, because they both fit under the PDM menu, we just moved them off the file menu and onto the PDM menu. So Femap does require the Teamcenter Rich Application Client, or the RAC, for implementation. And right now, still, the items need to be created in the RAC to use with Femap. Again, as we move forward, interaction with the Teamcenter Active Workspace is planned for a future version. So we will get into that later once we probably in 2401 or 2406 is when we'll start working with the active workspace. So if you're familiar with that, it's coming. It's just not quite here yet. So you can sign in, connect to the Teamcenter environment. You can check in, check out. You can do revisions with revision history documentation. You can create data sets that host the Femap.net modfem directly in Teamcenter, which you could not do before. And you can save and open Femap models too from the Teamcenter database using the save and open functionality. Now, one of these neat things that we kind of came along for the ride was just this ability to import a JT assembly. So the JT file, the Jupyter file, is Siemens' proprietary file. So essentially what we can do is we can write things to the JT file, and then based on the BVR, the BOM view revision, we can then basically just go grab the latest version of these files that we have stored in Teamcenter and then read them in the Femap. So that's something, especially if you're not using a parasolid-based geometry, can certainly be done. So then we just can read that in to the subassemblies, and everything can be read in directly from Teamcenter. Okay. Now, the one big thing that we did for 2306 with the Teamcenter integration was we actually just allowed you to pick your Teamcenter server environment before you kind of had to set this up one way, but now we just added the ability to kind of specify your servers, and then you can actually kind of move up and down the priority in the edit Teamcenter server environments, and basically kind of have it have you allow you to pick which server, Teamcenter server that you want to use. Okay, and then again, if you just want to switch it on the fly, it'll be available from that server dropdown. Geometry. Now, this may seem kind of minor, but we actually did a tremendous amount of work to do this. So Siemens has a standard set of PLM XML components, which are basically geometry translators. So now they offer, each one used to be a separate implementation, but now basically now it's one bundle. So when you implement the bundle, you basically get all the geometry translators that are available here at Siemens DI. So it took a lot of work to implement the bundle, but now it's basically you just kind of like, we just dropped the new bundle with new versions supported for each type of geometry into Femap build, and we're basically ready to go. So now that that's done, it should be easier to maintain our geometry translators moving forward. A couple new things too. We now have an interface to CATIA v6. We now directly support in Autodesk Inventor, and we also now support Rhino. So, and then you can just see the various files that we support there. One thing we also did was we used to have one option that was non-Nastran related, which was a CATIA v5 translator. Well, now that's part of the base product. So if you buy Femap, you no longer have to buy the CATIA v5 translator separately. It just comes along for the ride now. Another benefit is there's same user interface for all translators. Each translator used to kind of have a different interface. It's all just one now. And again, the big thing here to remember is this is just going to be, these components are well maintained, and it's going to be easier for us to keep the translators up to date moving forward. Pre-processing. The big thing we did for 2306 was rotor dynamics. So what is rotor dynamics? It's solution 414. Essentially, it's a well-established, recognized rotor dynamics technology. So it was actually a product called Simcenter Rotors. It's a best-in-class and complete rotor dynamics capabilities. It uses the Nastran input format. It just allows you to do industry-sized problems, and it's been proven to be able to do large problems. There's dedicated and streamlined workflows and scenarios. It's it has relative ease of use, and there's a somewhat short learning curve. And if you are using Enterprise Nastran, it's a tokenable solution, so just keep that in mind. So what we do in Femap, we added a couple of new things, and we're just going to go through each one of those here. New element property types, bearing, gear, and the Fourier element. New kind of dynamics entity types. Some very specific XY plot definitions, also the ability to enter bearing speeds and rotational speeds, and a couple of new load types, including unbalanced mass and unbalanced moment. So here you can see this is the bearing element actually is the CBear2 entry. It's just defined by two nodes in a coordinate system, whereas the bearing property actually writes the PBear2 entry with the type set to bear. So you can do constant stiffness, constant damping, and or constant mass. You can specify it, and you can see we have a tab dialog box here. So basically, when you choose each tab, you can enter what you want for stiffness, damping, or mass. Then along with that, it can also, there's also an option to be functionally dependent, stiffness, damping, and or mass. You can, the dependency type can be based on rotor speed, frequency, time, or it can actually have no dependency. And then just you can do hysteretic damping or proportional damping. And depending on which one you choose, it's just going to write a different thing out to the PBear2 entry. When we're talking about the C gear, it's just defined as two nodes at the center of two gears, separate rotors, and two coordinate systems. So, you know, basically you just pick two nodes and two different coordinate systems. And that's between two gears. It writes the P gear entry. So, you know, pitch diameter of gear divided by number of teeth, you know, the module of the gear, the number of teeth, pitch cone angle, helix angle, pressure angle, and a mesh stiffness coefficient. If it's not specified, the gears are simply considered rigid. The 4A element, it writes the FOU3 entry. It just connects a 3D node with 6 degrees of freedom to a 2D node of a Fourier multi-harmonic element, an actually symmetric element. At node B, you just have a couple options for coupling, either translational. So when it's translational, all the translational DOFs are coupled. Rigid, basically all 6 degrees of freedom are coupled. And then that's all DOFs. With rigid translational, it must be on a symmetry axis, must have the same axial coordinate, which creates a rigid connection between the translational DOF of the 3D node and the Fourier node. And this can actually be used with Siemens multi-step kinematic analysis type solution 402. And there is, and just note that there is no property for the Fourier element. Couple of new entity types. These are under just rotor dynamics. We just added a model rotor dynamics menu here. So we just have XY plot definitions, bearing speeds, and rotational speeds. Also, the model info tree offers the ability for all of these to create a new one, display the manager for that particular entity type, copy, edit, list, delete, or renumber the selected entities. So, and as you can see just on the right there, you can see that there's now just a rotor dynamics model branch in the model info tree that specifically holds these entities, these entity types. And as you can see, just basically each one of these is going to have a manager. I'm just going to kind of go through these quickly. So you define an XY plot request for nodal elemental or advanced output, and it writes an out MGT, case control, and corresponding both data entries. So in these managers, you can make a new nodal plot, elemental plot, advanced plot, or you can edit, show, delete all, copy, or renumber these. And basically, just you have different options for nodal XY plot versus elemental XY plot definitions. So for when you're doing the nodal, we're talking about displacements, velocities, accelerations, reaction force moments, and then elliptical orbit parameters. And then for an elemental plot, we're talking about stress, top, middle, and or bottom, or force, for elemental XY plot. And you can just kind of see what these create in Nastran there, the LM and LM group. For the advanced one, this writes that, and it just allows you corresponding values with other fields based on selected items, stiffness, mass, damping, and or results tabs in, kind of in the lower portion of the dialog box. These can be selected in the analysis set manager for these rotor dynamics analysis types. So like all of rotor dynamics is called solution 414, but there's a sub number that tells you kind of which type of analysis you're doing. So a 414-103 is eigenvalue analysis. This is actually only available when there is a transient response subcase. A 414-111, a harmonic analysis, or a 414-129, a transient analysis. So that's just what we're talking about in terms of the various rotor dynamics entity types. You can also specify a bearing speed. This is for when the dependency site of the bearing is set to 1 rotor speed. Again, it writes those particular bulk data entries, which can be used with the CBear and the PBear type. Again, you can create a new one, edit, show, delete all, copy, and renumber these rotor speed. These bearing speed. These rotor speed. Yeah. Then we also have. Yeah, and then for here we have bearing. I'm still in the bearing speed. So each one of these entries is written to a bearing element that is specified in the definition section. So you basically can just choose the rotor region 1, and that's the ID of 1 rotor region. You basically select 2 rotor regions when you're in the select rotor regions option, or you can specify a table which just writes the ID of a function to the speed field. And that's just what you can use to specify the various bearing speeds between different rotors. And then when we're talking about rotational speeds, this writes the omega 1 or omega 2. It's only for use with complex modal analysis. Rotational speeds are selected via the select rotational speeds dialog box here. And it's only available for subcases where the analysis type is set to 2 rotor complex modal. So you make a analysis set in Femap, and then you specify a subcase, and you just specify that subcase with the analysis type 2 rotor complex modal, and then you can select these. So again, the manager just allows you to make new ones, edit, show, delete all, copy, renumber. And this is pretty easy. There's only a couple of different variational types. You can do individual rotor speeds, values in the Y column of a function selected in the rotational speed table are written to the various kind of the omega I fields, WI there. It can do a linear sweep that writes omega 1. You basically give that one a first rotational speed, an increment, a number of increments, and then we have a logarithmic sweep, which writes the omega 2 as well. So all 3 options that are available in solution 414 are available in Femap now. Just some new load types. So the model load nodal command can be used to create 2 new load types. So you can make the unbalanced mass or unbalanced force. Both these require a rotor region to be selected. You can allow a function to be specified as a speed table. They're only for use with solution 414 and 111 and 414 129. And in that case, there's a drop down in the boundary conditions dialog box that you can use. And they are written to the UNBA bulk data entries referenced by the ULoad case control entry. So as you can see, for unbalanced mass, you essentially just enter a mass, an eccentricity, and potentially a phase, and it can be time frequency dependent. And then very kind of similar when you're doing an unbalanced moment, you just enter a moment value, an angle value, again, optionally a phase and some time frequency dependence. And again, that's what, and then it just writes out the appropriate entries, the appropriate values to the Nastran entries. Something for 2301, 2306 was arrow spline enhancement. Before, when you were picking arrow splines, if you happen to, and this is for anyone doing arrow elasticities, you had to select the boxes, which arrow boxes you wanted to use, that you wanted to connect to via an arrow spline. Now we just have there was an all boxes button that would fill out these, the box 1 and box 2. But if you changed the underlying arrow panel, arrow body, it would not update this. So now we just have an all boxes option here. Instead, if you're set to custom, you'd still have to come back in here and pick which ones you wanted. But if you're just set to all boxes and you change the underlying panel body, it's just is all taken care of for you, which is great for anybody who's making modifications to an arrow model. A couple great things we did with groups here. We did group operations condense. We now condense the group only to contain IDs of existing entities. Before we used to just do it to ID rules, and we would condense them. So you could end up with stuff in the group that you might not have wanted. So now it just basically checks to make sure that that ID exists, and it only uses IDs that exist to be in the condensed group. But we also did this. We did group operations reduced to existing. It works very similar to group operations condensed, but it updates each rule type to contain its existing entities instead of changing everything to ID rules, like condensed does. So this actually allows you to kind of reduce to the IDs of entities that exist in the group, but at the same time, it actually maintains the original intent of the group. So basically, instead of having to just go down to ID rules, any type of rule can now be condensed and reduced just to existing entities. And then for automatic add, if you did a renumber, what we were actually doing, this is more of a bug than an enhancement. If you did any type of renumbering, then both the old IDs and new IDs would both be added to the group. But now only the renumbered IDs will be in the group when you have operations automatic add turned on. So again, that's that's a strange one where you might have gotten some things where especially if you reused an ID range in automatic add, you might have renumbered and then basically had both sets of IDs, both your original and your renumbered set of IDs in your group. Meshing. So the mesh region command has been in Femap a very long time, but it was enhanced to a large extent for 2306. In previous versions, the node numbering needed to be in a very specific order for the command to create appropriate elements because you were basically going between two sets of selected nodes, kind of region 1 and region 2. The only requirement that remains is that the same number of nodes have to be selected in region 1 and region 2. So what you can kind of see here, if I would have picked 5 through 10 with a box pick, and then 141 through 171 on the other side with another box pick, I would have gotten kind of a strange transition there. What we did for 2306, if you did that same box picking, we basically just kind of figured out which side you wanted to come from, you know, and then kind of followed along. So you didn't need the same level of strict renumbering. So you can see on the bottom right here, that's basically what it would create now. Something, you know, a good bit more complicated here. So let's just say you had the starting model, and again, there's no geometry underneath. You could have just picked the side on the left here that's highlighted, and then on the other side, you know, basically pick the same ones. As long as there was the same amount of nodes on each side, what it could create and fill in was what you see on the left side here, where basically, you know, I told it to just put 3 across there. I'm sorry, two nodes. I mean, 2 elements across that gap, and then it actually missed this. It let this gap happen in the middle on purpose. So then what I could do again is I could basically just do the top and bottom now and fill it in with any number of elements from one side to another. And I don't know if you can well, you can't really tell just because this is kind of a top view, but this is a very, very, you know, curvy part. So it basically doesn't matter how like the curvature or anything, again, just as long as each side has the same number from side to side. So just again, that's just a nice enhancement to the mesh region command. Another one here that we did in 2301, hopefully everybody's been using mesh bodies and mesh on mesh commands. Well, the mesh on mesh commands, if you had line element stiffeners, your line element stiffeners would not be refined when you did mesh on mesh. So what we did was we added the ability to basically update the line elements along with the shell, you know, that were connected to the shell elements that were updating with the mesh on mesh command. We do have an orientation offset kind of deviation limit along, you know, angle along the edge that you can specify if you want it to, like if your line elements were to change by a certain angle. Like right now, it's kind of a tight tolerance. We don't really want you to be changing things all that much here. But if it's just all on a straight line like this, you basically can now go from this original model. So you can see on the refined mesh how all those line elements were refined, and on the unrefined mesh, basically, it just basically took it was able to take those line elements and basically kind of unrefine them and just essentially create the same mesh that you had in this one, but simply with less elements. So again, that was a mesh on mesh, mesh on mesh enhancement for 2301, and we improved it even more for 2306 for some very specific cases. Some performance improvements, 2301, again, this is 2301, and then it was, we did fix some things and added a few more things for 2306. So in Femap, we have two different pipelines. We have performance graphics and we have original OpenGL. When you're in when you're in best possible or performance graphics in file preferences, you're using the performance graphics pipeline. But certain things were still drawn in the original OpenGL. The drawback to having two different kind of pipelines for graphics is that the entity types only appear as expected in the graphics window in the original OpenGL. Things like line style, line width, fill style, and transparency were not supported by performance graphics. So, you could get some kind of rather different looking things between performance graphics and the original OpenGL. In an ongoing effort to improve the graphics, Femap now has a new unified graphics architecture, or UGA, which uses a single pipeline, and it will be implemented over the next few releases. When fully implemented, UGA will provide a better experience for the user, performance, hardware support, and both the performance graphics and original OpenGL pipelines will be removed. So basically, we're just going to one thing, and the option is actually called unified architecture in preferences. In addition, the unified graphic architecture will support those things like line style, line width, fill style, and transparency, along with being able to provide much better support for users actually using Intel graphics instead of NVIDIA or AMD graphics. So just something to keep in mind. What's in UGA? Again, you can go in the file preferences. You can turn it on just by turning on the unified the unified architecture option. And the things that are currently supported are coordinate systems, all the geometric entities, and geometry-based loads and constraints. So what we did for 2306 was behind the scenes, we did everything that was needed to be done to also handle nodes and elements in an upcoming version. So it's not quite in yet, but for 2401, it should be in there. Another thing we did was just improve performance of dynamic rotation in larger models. If a larger model essentially had a property defined for each element in the model, which in certain cases you might have, especially if you're doing some sort of solution 200 type of optimization problem. So basically what we had was, 2 million 10-noded tetrahedral elements and 2 million properties, which went from rotating at like 5 frames per second to between 30 and 40 frames per second on the same hardware. So a 6 times to 8 times improvement. Just basically, again, and that was without using the new unified architecture. That was just kind of something that we determined to using kind of the older graphics architecture, but it's also going to be implemented in UGA. So something to keep in mind. And that's one of those ones where, again, someone reported it at some point, and we took a look into it, and again, probably spent just maybe a day or two kind of looking at it and got a 6 times to 8 times improvement in dynamic rotation. Analysis and solver support. Again, for 2306, the big thing was rotor dynamics. So, and I'm just going to go through these relatively quickly. So, number 34 is rotor dynamics maneuvers. So that's 414-101. So linear static analysis with rotational forces. Just eigenvalue analysis. So we're able to compute modes of a rotating system at rest with 414-103. Complex modal analysis. So find the critical speeds and stability of a rotating system with 414-110. Harmonic response. Model rotating systems under synchronous, asynchronous frequency dependent excitation with 414-111. And then rotordynamic transient response, direct solution to model rotating systems under time dependent excitations. So that's 414-129. And as you can see, we actually added 5 different analysis types just because each one was kind of different. And having them all in one analysis type just called rotordynamics just was not going to cut it. Big one that's basically available for all of them is the Nastran Rotor Dynamics options. So basically you just kind of turn this on at the top, then you specify your various things. So you have So this dialog box is new and it's available for all Solution 414 analysis types. Some other dialog boxes that may be used for specific types include the select XY plot definitions, which we talked about earlier, and select rotational speeds, again, which we talked about earlier in the pre-processing section. Also, we added support for a few different parameters in this dialog box as well. So, and there you can kind of see those 4 at the bottom. And here we're not going to really go through all this just because it's basically just all the top was being written to the rotor D card. Okay. And then the parameters just, to specify what you want to do. And there is some neat stuff going on with the 2D and 3D results and 3D recombination. So what that does, basically it's the Fourier elements are incremented, at an incremental angle locations around to complete a 360-degree circumference. So basically what it can do is it can actually use axisymmetric elements, but then actually return elements in kind of a full 3D representation. Yep, just the rotor modeling assembly section. You have up to 10 rotors that you can fill in. So basically, you basically can just choose a rotor region. You still make rotor regions the same place that you could in earlier versions of Femap. So basically, they're in contact rotor region. So that's still where you do that, and they're node-based. So you can specify things on the region itself. You can only have up to 10 rotors at any time. That's just a limitation of Solution 414. And then you also just, you can make the rotor speed multiplier, you can make it functionally dependent, or if the function, it's just, if you enter a value here that's different than 1, you just get a multiplier of the speed specified that you have specified. Again, the XY plot definitions dialog, you can use this in 414.103, 414.111, 414.129. Some common icons that are used throughout Femap for selection and filtering of named entities are used in this dialog box. So if you have these defined, you have just options like select all, remove all, select which ones you have, turn off the ones you don't have, etc. And you can do some filtering. So if you've given them some names, you can certainly find them a little bit easier in there. And then very similar for set rotational speeds. This can only be used with 414.110. And when your analysis type in your subcase is set to rotor complex modal, again, just similar functionality that you see throughout Femap for selecting named entities. When you're in the boundary conditions, these kind of change depending on which type of Solution 414 you're doing. There's both a static load set and a dynamic load set. And depending on the type of analysis you're doing, and then also there's this Fourier multi-harmonics section that you can specify and where you can choose which harmonics to request or which harmonics to remove there. And then glued contact can also be used in Solution 414, so keep that in mind. Yeah, and this is just a little bit more about kind of what's available in each analysis type, like which additional. So for all the Solution 414 types, executive and solution options, bulk data options, that rotor dynamics options, and the rotor modeling assembly selection where you actually pick the rotors, those are available in each one. Then there's just some various ones that are available for your different solution sequences in 414. So some can actually have strategy parameters like Solution 402, dynamic analysis, XY plot definitions, etc. And just sort of kind of what's available. And this presentation will be provided for you, I believe, by Jonathan at some point. So an ATA. So again, this is just a little bit more about certain analysis cases you only just can enter a case ID. In other cases, there's actually an analysis type that can be entered for each different subcase, and you can kind of see depending on if you're doing maneuvers or eigenvalue analysis, complex modal analysis, harmonic analysis, or transient response, you basically just have some drop downs from the analysis type for your various subcases. So this was a big reason why we made different analysis types at the top level for our 5 different solution 414 rotor dynamics analysis types. Just to try to make things easier for solution 402, we took all the strategy parameters, the things that were on the NLCNTL2, and we put them each on a tab. This just made it easier. There's also now a default. You can just get defaults for the tab, or you can get defaults for all the options in the dialog box. So that was certainly something new. Just a couple of new things, it's just some additions here for, solution 414 in the analysis set manager. Something as well for strategy parameters. Again, just this check initial stiffness option can be used in solution 414 as well. We updated the name of control options to be strategy parameters, and we changed the name of the dialog box just in general to be strategy parameters. Because this actually used to be a number of different, this was actually this was all different sections in 2 different dialog boxes. And again, it could be a little confusing and overwhelming. So now it's just all tabbed. Something that was added for 2301 and then kind of enhanced for 2306. We added support for Nastran's simplified user interface to run response spectrum application runs. So now we just support those various options. So like RS apply, RSpector, and RSP opt. And then we included support for the new modal combinations method. So CQC, dsum, where the factor is now earthquake duration instead of just a factor. The group method and the rows method, and dsum is the double sum method. So then factor again for the rows and the dsum are actually earthquake duration instead of just a factor. And then for solution 2306, we kind of just went a little bit past this, and we added ability to use either the relative method instead of the large mass method for the base DOF option. And when we're using the relative method, you use this RSP loc entry, you do the coordinate system, you specify direction, and really the whole point, you're really supposed to be using this relative method with those new options that I mentioned on this slide here, the ones down at the bottom. So basically those new modal combination methods, the whole idea is actually to use the relative method instead of the large mass method for response spectrum application using those new methods. Added support to read Femap layup titles to from comments and input files. So that was kind of a new thing. And also added support to write 0.0 for stiffness values to spring damper properties, as this is viable for both MSC and Simcenter Nastran before we would flag you and basically say, no, you can't write this out, with the 0.0 stiffness for the spring damper properties. And then we just added a number of things for Abacus, more so when we write an Abacus file, we're writing it out more so as it would typically look from something like Abacus CAE. Kind of make our whole idea with both 2306 and moving forward into 2401 and beyond is to just make Abacus files, is to read and write Abacus files that just that look more like typical Abacus files than we created before. Oh, and also made improvements to exporting and importing the star tie keyword. Just a little bit about 2301 and 2306, just in case anybody missed it. We also added, just when you pick an analysis program and analysis type, we now actually show what it would be written to Nastran. So or ANSYS or Abacus. So like, you know, SEBUCKL for a buckling or solution 105. So we just use the combination to specify what it is, and we actually use some other options in that might be specified in the analysis set. So if we were doing a direct frequency, we, you know, based on what we have selected in the modal analysis in the Nastran modal analysis dialog box. So that's where, you know, we would know that we're going to be writing a solution 108 as opposed to a solution 111 for, say, a frequency, you know, so solution 108 for a direct frequency as opposed to a solution 111 for a modal frequency run. And then just another one we have down here at the bottom, just ANSYS, we write and type under, you know, comma modal if we have analysis program set to ANSYS and analysis type set to normal modes. So just trying to make it easier for folks who are more familiar with the nomenclature of a particular solver and used to looking at input files. Something we also did here for solution 402, and we plan on doing this in a number of places, is essentially we're only showing, so on like that, on that strategy parameters dialog box, now instead of showing just all the values in there, because there's probably 50 or 60 different parameters, instead of just showing values for all of them, we're now only just showing non-default values. And we plan to do this in other parts of the analysis set manager just as we move forward. This was just sort of the first step, and the one we're probably going to do next is solution 401. You know, our multi-step structural solver, just because that's probably the most similar and has the most different parameters on a couple of dialog boxes, essentially, or a single dialog box. So again, just showing the non-default values is just makes a lot more sense. Post-processing, very, 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 very important. For solution, if you're doing solution 414, it has no ability to generate an OP2 results file. Thus, support was added for attaching to Simcenter data file, the SCD5 generated by solution 414. The SCD5 is an HDF5 file format, and it's currently the only output which can currently be, it's the only output file which can currently be used for post-processing solution 414 results in Femap. So basically, you can do an attached file. Now, if you use load results from the analysis monitor, that pops up in Femap, and you hit load results, what it will do is it will attach in Femap, and then it'll do a save. It'll save that file depending on what you have set in preferences. If you don't have the attach option turned on, what it will do is it'll attach, then automatically save that attached output from the file into Femap. So just keep that in mind. So you'll actually see a kind of a command prompt appear, and it go through a number of commands to be able to read the output directly into Femap. So you'll end up with output stored in Femap instead of attached to Femap. When you are looking at the SCD5, you know, typically, you know, you want to look at it like in the I should say not from the SCD5, but from Rotor Dynamics in general. A lot of times you actually want to use our complex results options, which are available, kind of our on-the-fly ones here. So you either can look at a deformed plot just at a static display phase angle, or you can look at an animation of a single output set based on an animation phase increment, where basically it's just gonna show you an animation of that single results file based on that animation phase increment. So if it's at 15, you'd see that, you know, it's just going to go 15, 30, 45, 60, 75, 90, etc. You know, and it'll just keep repeating that to animate your model. So that's a great way to look at any solution 414 solution that provides complex results. And the other big thing is Campbell diagrams. So that's typically what most folks are looking at from a solution 414 analysis. So, the results from the XY results are read in as functions in the Femap, and then you can just use any of Femap's functionality in the charting pane to chart your Campbell diagrams. And a lot of times what you want to look at is, the lines with 2 points only kind of originating at 0, 0. The 0p line, that's kind of the one down there at the bottom. And then the 2p line, that's the light blue cyan colored one that's going up. And then where they cross, these various things are the critical speeds. So a little bit about computed vectors, 2301, 2306 functionality. So basically these allow you to capture additional key results data that may not have been calculated by the solver via model output computed vectors command. What you do in here is you have two choices. You can automatically create them when results are read or created. And by created, that would be commands such as using something like the model output process to make a linear combination or an RSS combination, maybe an envelope. Or you can just have it do it now in existing output sets at any time. So depending on what you have, selected at the top, then you can choose whether you want to auto run it or run now. And then when you're in the now and existing output sets, you actually get a compute now button at the bottom. You have two different kinds, standard and user defined. So standard, we have Elementa results. The one that's on by default is the plate, solid principles, and invariants. Just in case the solver has not calculated them automatically, we always had this turned on in the preferences. Now it's here. So basically you can just, that one's always going to be set to auto run, but say beam bar von Mises stress, plate average, mid stresses, strange. And that one was actually a preference that you could turn on before. So it was always just giving you the middle. It wasn't doing a calculation. It was just simply doing an average of top and bottom. So just keep that in mind if you're going to try using that one. Solid plate, solid failure theories. You can have it calculate those now. Laminate failure theories. So let's just say you were doing a linear combination or RS combination. These were not being automatically calculated, but again, you can just turn these on now. So if you are creating combinations, it'll also be able to do laminate failure theories. Just so everybody knows, these are the same exact laminate failure theories as Nastran uses. So I mean, it's if you're looking for the way that they're calculated, check out the Nastran documentation. And then just some envelope results, things like beam all locations, just show you the highest one from there. Plate top, bottom, or laminate all ply. So you can think of like a ply summary can automatically be calculated. Plate, laminate at all locations. And then solid all locations, just if you wanted to do that. Again, most of these could have been done with solid output process before, but these are just some nice hard-coded ones in here now. Now, on the user-defined tab, you can also make your own combinations, your own envelopes, or if you like, you can actually create an API script where basically you just choose which one of those you want, and then you can do define. And when you do define, depending on whether you're making a combination, an envelope, or an API script, you get a different dialog box and you just have some various options in here. So if you're just doing a very specific combination or you're always doing that or a very specific envelope, you can just specify these and then you can just have these set to auto run over here in the user defined section. And then if you really want, what you can do, let's say you needed to run these in a particular order. If you need to do that, you can move them up and down in the list, and then it basically just starts at the list, top of the list, and goes down from there. So if one further down the list needs the first one to be calculated first, it'll do that, and then it just knows to do that. So if you happen to put them in a funky order or just not the order you want, you can move these up and down in the list and basically have it be able to do the calculation, then do your further calculation based on a different user-defined calculation that you did before. And then down in there at the bottom, we actually just have the ability to save or load these from a library. So you can also specify that in the preferences as well. Okay. Just some miscellaneous things. We added a command finder for 2301. We did quite a bit of an enhancement for 2306. So anything that's in a meshing, like in one of the toolboxes, if you go looking for it, should also now pop up in here. And if it is in a toolbox, that tool, if you select it, that tool will be open and it'll kind of pulsate a few times to draw the user's attention to where the tool is. And it also allows you to search before, and in 2301, it was really only searching the names of commands. It wasn't really doing anything further. But now we added some keywords, especially based on the nomenclature found in other CE applications, like equivalents and grids. Like if you wanted to do a tools check coincident nodes in Femap, what you would do in Patran per se was actually, you would equivalence grids. So like if you were to put something like equivalence grids into Femap now, that would take you directly to the coincident, the tools check coincident nodes command. So again, and we're just going to keep adding to those keywords as we move forward. So again, that's just the command finder. A little bit about our digital product experience and product excellence program. So it's basically designed to help us know how people are using Femap, which commands, etc. We had to make some changes, basically to comply with some new data privacy rules and laws. Just always remember, if you've turned any of this on, this has been in Femap for a while. No proprietary or personally identifiable information is collected. Participation is completely optional, and it does not affect product performance at all. What it does is it just is able to it just reports back through certain channels kind of what commands are being used and in what order and that sort of thing. And just some new API functionality for 2306. There's the new geometry interface object for all those new geometry translators. Everything related to rotor dynamics is now available through the API. And then just some additional ones here that actually just kind of gave access to commands that we changed that we essentially did not create new API functions to handle all the options in the new commands. Yeah, and then for 2301, the computer vectors object, those new group commands and some and the mesh splitting command programmatically, and then just some other ones there. If you're new to Femap and you want to try the Simcenter Femap for free, we do have a 30-day free trial on the website, so you can go find that. And I think Jonathan, I don't know, but I think ATA might have a link to it on there on your website. But we can go through that later. Oh, there it is. I mean, it's siemens.com/try-simcenter-femap, and I'll take you there. And then one other thing I just wanted to mention while we're going through this is we have the Simcenter Femap community. You can explore it. There's blogs. There's articles you can share. You can ask questions on the forum. You can get answers, connect with other users, and benefit their experience. And then you can learn. There's also a knowledge base that you can get to from the Femap community, and it's actually available just via the help menu in Femap. So there should just there's a command help Femap community. Might be down a level, but I think it's just help Femap community, and then I'll take you directly there. So, and then if you wanted to know its location, siemens.com/plm community/simcenter, and that should get you there. And that's all I got. Jonathan?
Awesome. Thank you, Andy. That was great. Yeah, and I'll also echo the community site is great. Let us know if you want a free trial or anything. So yeah, thanks again, Andy. We do have a couple questions in the chat, and I'd encourage folks, if you have others, to keep bringing those in. So Andy, I can sort of moderate those in if that works. So the first, I think, is that you mentioned Femap 2306 now supports CQC combination. Does that mean that Nastran can do that itself as well?
Yeah, I mean that's how we're doing it. Yeah, I mean those modal combinations are being done by Nastran. The only thing that we're doing by selecting CQC is just writing that to the input file and telling Nastran that that's the way we want to do the modal combination for the response spectrum application.
Okay, thanks. And then a couple license related questions. The first, can parts of the Femap advanced bundle, so specifically things like super elements and DMAP, as well as desktop extension, be enabled by Simcenter 3D tokens?
Not currently. But that is certainly something that we've been thinking about doing. If you have Simcenter 3D, well, if you have tokens that can run Nastran, you can always just try to. But you need to run. You would need to run. Actually, here, you know what? Why don't I just go back here for a second? I'll just kind of show you something that I have back here. What you would want to do. Yeah, here's as good as any. Oops, to kind of show you here. You can always set up a link solver to run enterprise Nastran. You can do that. You can also do so if you actually have the ability to set up, if you have the ability to access enterprise Nastran, whether it's either through tokens or just through a license server, you can use either the integrated solver here, and you can actually say license type, and you can actually change this to enterprise. Okay, and then if you change that to enterprise, then you can specify your enterprise Nastran server location. You can actually do that on the in file preferences on the interfaces tab. There's just a place to enter your enterprise Nastran server location, and then if you change, so then if you're an integrated solver and you change to enterprise, it'll use that. I do not know if that can actually, well, actually, I think if you have your enterprise Nastran set up to use tokens, it should certainly work. But as far as using tokens where you're actually using, like, say, the integrated version of Femap through the desktop to run, you cannot then have it use tokens to run like an additional thing like super elements or arrow elasticity or anything. But again, if you have access to run it via enterprise Nastran, that should work by just pointing to that license server that's serving out the enterprise Nastran licenses or tokens.
Okay, yeah, makes sense. Sort of related, like I know personally in my own workflows, I used to use both Simcenter 3D and Femap, and I would sort of go back and forth depending on what I was doing. I've heard that there's now an option where you could get both Femap and Simcenter 3D together. Can you share any details on that?
That is just that's a relatively new product. So basically it's just called it's just called a bundled product. Jonathan, I will send you the exact part number or product number for it. But that's a relatively recent thing. Yes. So basically, if you purchase that product, you do get the ability to run both Simcenter 3D and Femap.
Sweet.
Yeah. Okay, go ahead.
And then, yeah, final license question. I've heard a little bit of the salts licensing tool. I don't personally know anything about it. Can you share what that is and if it's coming to Femap and how that might affect, especially like, node locked dongle users?
As far as the SALT licensing toolkit, I mean, so that's Siemens Advanced Licensing Toolkit SALT. Essentially, we're going to be we are moving to SALT. We're not there yet. To some extent, if you get a subscription version of Femap, it is using SALT in the background to be able, in order to provide the license and everything of that nature. We will be moving to SALT. What you can do what you can actually do with a dongle, and this can be a little confusing, is right now we have two different mechanisms for looking at like how we check out a license. We either check it out via FlexLM, obviously that's a floating license, or we directly read the dongle. Now, once we move the salt, what'll happen is it uses a single mechanism, but instead of it reading the data directly from the dongle, it essentially uses the dongle as an encryptor. So then it basically can, so it's going to be using, you can think of it this way, it's going to be using Flex, but Flex is going to be looking, like it uses Flex LM in the background, sorry. It's still going to be looking at the dongle, it's just going to be looking at the dongle in a different way. But your dongle can still be used to license Femap. It's just the mechanism behind it is just going to work differently.
Okay.
So, and salt will either be available in 2401 or 2406. It all depends. There's still some kinks to work out on both their end and our end in terms of the salt licensing. So, but we are certainly hard at work on it over here to get everything up and running and working. And we found some issues. We had some issues in our own code. They've had some issues on their side, but it's slowly but surely it's all getting worked out.
Okay, awesome. Yeah, thanks for that. I am going to steal back the screen just to throw up our contact slide. I haven't seen any other questions come in, so maybe just a final question for you. What are you excited for in the future of Femap? Could be, something in 2401, 2406. I realize the end of the year is like sneaking up on me. So like, what are you excited for in the near future for Femap?
We have a few things. We have a few things kind of in the works over here. Some solid additions to the computed vectors is certainly something. A better interface. I shouldn't say a better interface, but just a more complete, a more comprehensive support of super elements, like even perhaps being able to show them in the screen. Even if it's just just sort of, you can think of almost like a spidery thing from a symbol, just kind of out to the connections back to the residual structure. That's certainly something we've been talking about. And just our continued support of Simcenter Nastran, and just again, I kind of glazed over it, but we're really focusing on our Abacus support coming up as well. So those are some certain things. And then a little bit further down the line, we really are hoping to get some sort of assembly structure, like a assembly FEM type of structure inside of Femap. Whether it's to what extent that is going to be is still very much up in the air, but that's not going to be for 2401, but that might be coming around the corner. Just even if and it could be as simple as just giving people, for lack of a better term, buckets to put kind of sub-assemblies into, or it could be at a much higher level. Again, we are still kind of scoping out that functionality, but we just think that would make it a little bit easier. And then of course through our geometry translators and things of that nature, just we might be able to then also just handle assemblies in sub-assemblies from the geometry side a little bit easier as well. So.
Very cool. Well, lots to look forward to. Andy, thank you for the excellent presentation today. This was great. Thank you for all of you who called in and dialed in. Thank you for joining us. And I hope everyone has a great afternoon and hope we stay in touch. Thanks, everyone.
Yeah. Thank you, everybody.